All right, guys. Welcome back. So last time we talked about some of the basics of big data analytics. So we're still in the introduction section, but today we're going to talk about some of the basics of Google Colaboratory. So like I said in the first class, we'll be using Python as our main programming language. The reason for that is many, because first of all, Python is quite easy to use. It's very powerful and versatile. And maybe because of those reasons, nowadays is one of the most popular languages. And I think when it comes to the data science, it's the most popular language among many others. And overall popularity is keep growing. And then the community is large. So when you have some problem or there's a good chance that you'll be able to find a solution already solved by somebody on the internet. So that's, I think, one of the advantage of a popular programming language. Also, Python comes with a lot of off-the-shelf packages. So having a large community also mean that there are a lot of developers working on Python. And what they do is they develop a lot of different things, and then sometimes they just share it for free, which means now you have a large library of the algorithms that you can just borrow from. Okay. So that's a great advantage of using Python. Now, like I said last time, if you're not quite sure if your Python skills is proficient enough, there's a test available on Icon. Oh, and by the way, for everyone must take the Python quiz. For people who are already familiar with Python, it's not going to take too much of time. It's fairly simple. So for those of you who are already proficient, I think taking the quiz is going to take about 5 minutes or so. So you must take the quiz because that's going to be included in your performance evaluation. Now, in order to run Python, there are many different ways of configuring Python development environment on your system. But I want to talk about this new way of getting started with Python, which is called the Google Colaboratory or Colab. Colab is a free online development environment which allows you to write and run Python code directly on a web browser without having to install anything on your computer. So it allows you to share your code, run your code, and collaborate on the code with the others fairly easily. So you can think of it as like a Google Docs, if you will. So it's actually a very nice platform for learning Python as well as data science without really having to go through all of this frustration of installing things and then configuring the settings and environments and things like that. So without hassle, you can jump right in, and that's the advantage of Colab. So what we're going to do today is we're going to go to colab.research.google.com. That's where Colab is available. So let me stop sharing the slide and then switch it over to Colab. There we go. So again, if you type colab.research.google.com, you'll find a screen like this. Well, I guess it's a good time for you to kind of take a pause and then open your web browser and then try to log in to Colab. So if you already have a Gmail account, you can use your Gmail account to use Colab. If you don't have one, then you probably want to sign up for it because it's really worth it. Of course, if you have other configurations, then you should be fine to use your own configuration. But I recommend you to use Colab, at least for this course, because of a lot of reasons that we'll come across later. Okay, so the game plan here is, instead of trying to set up Hadoop and Apache Spark and everything, we are actually going to use Colab, and then we'll borrow the computing power of the Google computing server, as opposed to setting everything up from the scratch on our own. And because of this remote mode of instruction, I believe there are people who has not so good computers like me, and for those cases, I guess Colab is going to be a super powerful solution. So what you're gonna do is to click New Notebook, or if you don't see this pop-up window, alternatively you can click File and then New Notebook. And then after a while, a tab will be loaded with a fairly simple interface. So this is what a Colab notebook looked like. So if you're completely new to Python, I must explain some background about it. So in Python, there's this thing called a Jupyter Notebook. So Jupyter Notebook is an interactive Python development environment, which allows you to write a code as if you're writing a note on your notebook. So that's where the name came from. So Colab is based on that Jupyter Notebook. Okay. Now the interface is pretty simple. So as you create a new notebook, what you're going to see is this small box over here. And then what you can do is you can type a code like this. Let me blow this up a little bit. There you go. So you can, for example, type hello world. And then you can click this play button. And as you do that, then you will see this string, hello world, getting printed on your screen. So that's what Colab Notebook can do. And you can move your mouse cursor down to the bottom of your cell, and then click this button, plus code. Okay, by clicking that, you can create a new box with a play button like this. So by the way, the boxes with the play button are called code cells. And in the code cells, what you can do is literally to type code using Python. So like this, 1 + 2. In case you're curious, you can type it and then click the play button. Then you can see that the result of computing that is being printed on the screen. You can also, do a lot of different things. So if you already know Python, this is basically like a Jupyter Notebook. If you're new to Python, then this is basically how it is. Now, when you use Colab, there are some useful shortcuts. One thing is, instead of clicking the play button, you can hit Control-Enter. So press Control key and then Enter key. And by the way, if you're using Mac, instead of Control, you must press Command key. Okay. So either Control-Enter or Command-Enter has the same effect as clicking the play button. Or you can also hit Shift-Enter, and then it'll execute the current cell and then move your cursor to the next cell. So this can be really useful when you're writing a long, code. While my screen is being loaded, there's a question on the chat window. What does number mean on the executable statement? So if you look at the screen, you can see numbers with square brackets. So let me highlight where I'm looking at. So if you look at the left of the box, you'll see the numbers. That's a good question. So the numbers indicate the order of the code being executed. So here, let me clear my drawings and then show you the difference. So and to do that, let me restart runtime, which is basically like pressing a power button and then rebooting the computer. So at the beginning, you don't see any numbers, right? So the square brackets are empty. What happens now is if I play this one, the first cell, then it runs the computation. And then as a result of that, now you see that the number has changed to 1. Okay. Again, if you look at the second cell, you'll see that the number is empty. The square bracket is empty. Now, if I run this second cell, then you'll see that the number has changed to 2, right? Now, if I go back to the first cell again, okay, which used to have 1 in the square bracket, if I run this cell again, then what happens is the number will change to 3. You see that? So the number indicates the order of operation, because this is something that you might be a little confused if you are used to like C++, for example, where everything is compiled before running the code and then executed all at once. Python is not like that. So what Python does is it compiles line by line as you run the code. So what that means is, no matter how long I write the code here. So let's say I created a lot of code cells and then I type lots of codes, right? That doesn't mean that when I run the first line, the compiler is going to compile everything and then convert that into a binary, instruction for executing on an operation. Instead, what's going to happen is the moment you click the play button, the Python compiler compiles what's in the cell only, and then run the line. So because of that, things, some weird behavior may happen. So for example, I define a equals to 7, okay? And then let's say I'm printing a over here. So if this was C++, for example, then the compiler at a compile time will return error because we're trying to print a before a is defined or declared, right? But in Python, this might be okay depending on in which order you're running the cell. So for example, if I run this cell, says a equals to 7 first, now, and the ordering of that is 4, all right? And then go up to the first cell and then run the code, then as you can see, it is printing 7, which is the right answer. So the ordering really matters in this case, right? Because you need to run this cell first down below before to run this first cell, okay? So that's basically how Python works. So if you're not used to it, it may take some time to get used to it, but once you get used to it, then I think you should be fine. All right, so where was I? Yeah, So I was going to explain some useful shortcuts, and I was in the middle of changing my setting. And for some reason, it's very slow. Oh, there you go. Okay. So by default, probably you'll have this this option, automatically trigger code completions, checked. I think that's the default setting. So what happens then is if I type something, then it automatically pops up this code completion, okay, to help you typing the code and help you remembering the names of the functions and things like that. And then as I hit parentheses, then it pops up an automatic suggestion in terms of how this print function could be used. Okay, so you can see that the list of the inputs that the print function is expecting alongside the explanations of what those inputs are doing. Okay, but in my case, I prefer to turn that off. So what you can do is you click the settings and then click editor and then turn off automatically trigger code completion, because sometimes it can be really annoying. You know what you're doing, but Colab still wants to make suggestions. So in those cases, it's kind of annoying. Instead, you can turn off that option, but whenever necessary, you can hit Tab key. Okay, and as you hit Tab key, it's going to pop up this code completion menu, so that you can kind of cheat a little bit, right? When you don't remember how to use the function, what the function name was, and things like that. All right. So what else do I need to cover? Yes. So so I don't intend to do any Python lecture today, because there's already a video available, and then there are some materials that I posted on Icon. So again, if you want to kind of brush up your Python skills, please go ahead and take a look at that. Now, one thing I want to show you is, by the way, let me clear up the screen a little bit. So one thing I want to show you is here. So I explained what the code cells are, but I did not explain what the text cells are. So similarly, move your mouse cursor to the position where you want to create a new cell, and then click text, okay? And in that case, it's going to pop up a cell that looks slightly different than the code cell. So this is one thing I really like about Jupyter Notebooks. In the text cell, what you can do is literally to type some text for the sake of note taking. So this is a note. So as you write a code, sometimes you want to keep a note. Sometimes you want to kind of organize your thoughts into a writing, or in case you're collaborating with your collaborator, you probably want to explain what you're doing, what you're thinking, so on and so forth. So text cells are quite useful for those kind of situations. There's this thing called a markdown language. So markdown language is not really a language, but it's kind of a script that allows you to create web documents fairly easily. So for example, sharp is a markdown key for creating a header. So this is a header. So if I type like this, on the preview, you see that the header was created. So it's much larger in size. If you want to have a subheader, just hit sharp key twice, and this is going to be a subheader. So you can create the subheader by having 3 sharp keys. You can have 4 sharp keys. but I'm not going to show you. You can also create a list by the dash, okay? And then you can just keep writing things like this. And you'll see on the right, things are nicely organized with the bullet points. If you replace dash with 0 dot, then you can see that the bullet points are converted to enumerated list. So it begins with 0, but you can be more explicit and then, say it's, 1, 2, 3. So in that way, you can create an organized note about your code. There are many other, markdown commands, which could be looked up by, a simple Google search. So I'm not going to explain all of that, but knowing a few markdown commands is going to be actually quite useful. So in case of text cell, obviously you cannot execute it. So if, for example, if you type whatever complicated equation that you type over here, it's not going to evaluate that. It is just going to recognize that as a text. So Control Enter, hitting Control Enter doesn't work. If you hit Shift to Enter, it'll just move your cursor to the next cell without running anything. So text cells are literally just for note taking. Okay. Now this is something that you might not know, even if you have previous experience with Python, which is this exclamation mark. Okay. So I'm not sure how many of you are familiar with the Linux system commands, but Google Colab basically operates on this Linux system, and you can actually use those Linux system commands to navigate within that virtual computer, or download files, or extract zip files, or whatever you want to do. So to do that, exclamation mark is what you want to use. So exclamation mark, for example, date. So date is a Linux command to obviously to look up the date and time. So as I type exclamation mark date and then hit the play button, you will see that the today's date and time is being printed out on the screen. Okay. The time is in the UTC, so it's not your local time, but you need to do this conversion. Date is not really the most useful command, obviously, but what can be useful for you is this command called ls. So ls means the list, okay? And what it does is it'll list the contents of the folder that you're currently in, okay? Now, Google Colab is a sort of a virtual computer that you remote in, okay? So what happens here is as you create a new notebook, Colab allocates a computing node in one of the Google server farms, okay? And then, within that allocated computing resource, you're assigned a virtual computer. So it's not, really like a physical computer sitting in front of you, but it's a virtual computer that you are remoting in. And then what happens is, as if you're using an ordinary computer, it has your user folder. It has, all the basic, folder structure of the Linux system. It has everything behind the scenes. So right now you're in the user folder, and then by default there's a folder called the sample data. Okay. By the way, in Linux, folder is called a directory. That's kind of an old computing jargon. So you have in your current user directory, there's a directory called sample data. Now, what you want to try is to, for example, ls spacebar sample data, okay? And what this is going to do is to list the file contents within that folder that you just specified. So I want to list the contents of the directory called the sample data. That's what this command is about. Okay. What else? Another useful command might be wget. Okay. So wget and then type some URL is going to allow you to download a file contents from the URL that you specify. So for example, I don't know, what would be a good example? So I'll just search an image. Well, in fact, I have a better example. Yes, maybe I can go to the UCI machine learning repository. Sorry, it's taking too long. So the website that I'm connecting is called the UC Irvine machine learning repository. And then there are thousands of machine learning and machine learning algorithms. And sorry, it's way slower than usual. So this is the UCI machine learning repository. I'm just going to click this favorite data set called the iris data set. And then if you click data folder, you will see the contents of the data set. Okay, so in this data set folder, we have iris.data, iris.name. So I'm going to just copy. So right click and then copy link address. And then I'm going to move back to my Colab screen. And I'll type that URL right after exclamation mark wget. So as I run this code, you can see that the iris.data file has been downloaded. And to check that, what you can do is just simply type ls. And now you see that in addition to the sample data directory, there's this iris.data directory, iris.data folder. Okay. If you're curious about the file content, here's another command that could be useful, which is cat, and then type the file name. And by doing that, you can see what's inside of that file. So it seems like a lot of numbers are encoded in the file. So we have 4 numbers. Those are, by the way, parameters that describes the shape of the flower, iris. And then here's the tag for the class of the flower. So it's a data set that's comprised of the 4 numbers that describe the shape of the flower. And then here's a class label. So there are 3 different types of iris flowers, and the file contains those information, okay? So that's basically how you can download a data set from the web, or download a file from the web, and then, see the contents in it. Another useful command is, because a lot of data sets are in the form of a zip file, you can do simply unzip and then file name .zip. Okay, so I'm not going to show you because today my computer is not cooperating with me very well. So, but it's a fairly simple command. So if you type exclamation mark unzip something something .zip, then it's going to extract all the contents inside of the zip file, and then you'll be able to see the result by typing ls again. Okay. So those are the useful Linux commands. Now, if you are new to all this, what I recommend is to take a look at this website. So this is an open courseware provided by MIT. It's called the Missing Semester of Your CS Education. That's the title of the course, and I find it really useful. And then their first lecture is actually about some Linux system commands, or the bash commands. So it's just one session that talks about the Linux system commands. So if you're curious about it, go ahead and take a look. And it's not going to be a major time investment. Okay. And just as a word of advertisement, in this website, you can also find a lot of other useful informations like Git and a lot of other tricks that you don't really you don't necessarily learn from computer science curriculum. So I find this website very interesting and quite informative. So I strongly encourage you to check it out, and at least go over the first lecture that talks about the Linux commands if you're not already familiar with those. Okay. There are a few minor things which I prefer to skip. So you must actually know some of the Linux commands in order to operate on Google. And by the way, if you go to the real world and find a data science job, you will need to do this anyways. Okay, so a lot of big data systems and computing servers and things like that, they force you to use those Linux commands, because that's not only more efficient, but also well, I think the efficiency is the main reason. So you will need to learn those things anyways. So I think this is a good chance. And as a matter of fact, the commands that we use are quite limited. So you don't really have to become a master of those Linux bash commands. Instead, knowing how to create a folder. Oh, which, by the way, I forgot to explain. So for example, how to create a folder. So mkdir, make directory, is how you create a folder. So let's say I type exclamation mark mkdir, new folder. Then it creates a new folder. So how to check that? Just type ls. Then you'll see that there's a new folder created. Okay. So there are some basic commands, like how to create a new folder, how to download something, how to copy a file, and to make a clone. Once you master those basic commands, I think it's less than 30. So those are the things that you want to memorize. Beyond that, it's not really necessary if you are going to be a data scientist. If you're like a network engineer or database engineer, then obviously you need to know more than that. But as far as data science and machine learning is concerned, knowing those small number commands is going to be what you need. All right, any other questions? Okay, so one last thing I want to show you before I move on to the next thing is this. So if you click Tools and then settings. Then it'll pop up something like this. And then, not editor, site, no, sorry. I forgot where it was. Maybe cancel, sorry. Go to edit, notebook settings. Yeah, it's a little bit confusing. So under edit, there's a menu called the notebook settings. And then here you can see this thing called the hardware accelerator. Now, if you click the drop-down menu, you will see the GPU option or TPU option. So this one is not really necessary for this course, okay? What this thing does is, by default, you don't have a hardware accelerator. And what that means is you'll do all the computation on a CPU. But in case you want to do more, do a faster computing, then there's an option for you to switch over to GPU, graphics processing units. And GPUs are much, much faster for certain operations. For example, doing matrix algebra, GPUs are much faster. So nowadays, for example, neural networks, GPUs will give you, a significant amount of speed gain. So what I wanted to tell you is that there is an option for you to switch over to GPU in case you know how to utilize GPU. But another thing I want to mention is that doesn't necessarily guarantee that your code is going to be converted to something GPU compatible. Okay. So in order to use the GPU option, you need to write a code that is compatible with the GPU computation. So for example, there are libraries that supports the GPU computing. For example, TensorFlow is one of the popular deep learning library. Neural networks are implemented over there. And for that, they have written everything already in a manner that is compatible with the GPU computing. So by switching over to GPU, you can leverage the computing power of the GPU. And then Google actually generously offer pretty decent GPU. So you can have quite a bit of speed gain. However, most of the things that we'll do in this course, we're not going to use GPU, okay? Almost 99% of the things we're not gonna require GPU. And that's actually the beauty of what we're gonna learn. It's called Hadoop and Apache Spark. Hadoop and Apache Spark allows you to analyze big data without having to purchase a fancy hardware. So instead, what we do is we're going to leverage the power of distributed computing. And since we're learning a software framework that is based on non-GPU mode, we are not going to use any of the GPU power in the Colab, okay? I just wanted to mention, okay, in case anyone has an interest. Sorry, I forgot it again. Edit notebook settings. I mentioned that just in case anyone is curious. But again, for this course, we're not going to use the GPU acceleration. So please just keep it as none for the hardware accelerator setting. Because if you occupy GPU, then that means there's somebody else, right, in the world who will lose the access to that GPU because the GPU power is allocated to you, right? So for the other people, do some good, okay? Just keep it as known, and then keep that as your setting. All right, so I'm seeing some questions. Oh, I guess it's already answered. So, all right. Any question before I move on? All right. So then I'm going to explain something else today. So basically two things. We're gonna talk about in the next class. We're gonna talk about Hadoop and Hadoop ecosystem. And Hadoop is basically a software ecosystem that has all the necessary technology to enable big data computing. Okay. And in the Hadoop ecosystem, there are a lot of different technology, and one of them is called an Apache Spark. So Hadoop and Apache Spark are the main things that we're going to learn. And obviously, in order to, you will need to have Hadoop configured on your system. Okay. Now, for that, here's one option. So the simplest way to install Hadoop on your computer is to use this thing called the Virtualbox. A Virtualbox is basically a virtual computer that you can install inside of your computer. So you can run a virtual computer within your actual computer and then install Hadoop inside of that Virtualbox. And in that way, you don't have to worry about, different system settings and, all this kind of things. You can just simply download the Virtualbox, install it, and then download the Hadoop distribution, and then, launch it within the Virtualbox. The procedure is fairly simple. Go to virtualbox.org. And then if you go to their website, there's a big button that says download Virtualbox. There's no way you can miss it. It's a huge button. So click this one, and then it's going to download a Virtualbox installer. The installation process, again, is fairly simple. What you're going to do is just click next, 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 and then the installation will be done. You don't want to change the default setting unless you know what you're doing. So I recommend you to keep the default setting. So that means just keep clicking next, next, next. It's taking a little bit of time, but as you click the download button in the main page, it's going to direct you to the download page, which contains different versions of Virtualbox distribution. And all you need, here we go. So what you need to do is, here at the top, you see Virtualbox 6.1.12 platform packages. And if you're a Windows user, you want to click Windows host. If you're a Mac user, you can click OS X. If you're using Linux, you can click Linux distributions. Okay. Now, Hadoop is running on Linux system. So for Windows users and Mac OS users, installing Virtualbox is, almost necessary because Windows is a different operating system than Linux. So what you need to do is to create a Virtualbox and then, install Linux on that Virtualbox, right? Same thing with the Mac OS. Even if you're using Linux, I still recommend you to install Virtualbox because configuring all, the environment for Hadoop is going to be really, really tricky. So again, even if you're using Linux already, just download the Virtualbox and then create a virtual computer inside of your Linux machine and then configure Hadoop within that environment, okay? So once you download everything and install Virtualbox, this is going to be the window that you'll be seeing. It looks fairly simple. Now, what you're going to do in the meantime is to go to cloudera.com/downloads.html. And if you go to this website, there's this menu called the Hortonworks Sandbox. And Hortonworks is a company that used to manage the Hadoop distribution. Now they're merged with this company called Cloudera. So that's why this thing is within there. So if you click this button called the download the Hortonworks Sandbox, you'll be directed to a download website. And on that download page, they're going to ask you some survey questions. But after you answer that survey question, you'll be able to download Hadoop distribution. So what you want to do is, here's a Hortonworks HTTP. So that's what you want to download. So if you click this one, download now, then you'll be directed to a page where, why is it so slow? Yeah, so you'll be directed to a page where you can choose the installation type. So if you click this drop-down menu, there's an option for Virtualbox. So click this one and then hit Let's Go. And then here's a survey that you want to finish. So why are you downloading this product? Because my professor asked me to do. And then you type the name, last name, business email, company, job title, phone number, and then click continue. I'm not going to do that, but after you do that, then there's going to be a download link pop up. Okay. The version you want to download is 2.6.5. The newest version is actually 3.0 point something, but you probably want to stick with the version 2 because that's more stable. Okay. Now, after all of that is done, you're going to have this button called Hortonworks Sandbox HTTP. Okay. And then by clicking this, what happens is you're basically pushing the power button of your virtual machine. And then after a while, you will come across this screen that doesn't look very user-friendly. And at the end, you'll be running a Hadoop server on that Virtualbox. And this is basically how the Virtualbox, the Hadoop Sandbox hosted on the Virtualbox looks like. Okay. So this, what you're seeing, is Hadoop. A lot of things are going on, and there's some funny names over here: Yarn, Zoo, Hive, Uzi, Pig. There are a lot of weird things going on. Probably you feel like it's too complicated, but once you learn the basic concepts, which is going to be next week, then things will start to make sense. Okay. So today, just to show you how things work, I'll just give you a brief example. So one of the technology in Hadoop is this thing called the Hive. And while we're loading it, there's a question on the chat window. Are we downloading the 6.5.5? Yes, 2.6.5 version is the one that you're downloading. Did anyone have success with installing it on Mac? I don't know. Maybe for that, I'll open up a discussion board on Icon so that you can share your experience about downloading and installing Hadoop. Well, and this is actually going to be something that I'll say at the end, but I was gonna tell you at the end, but you don't really need to install Hadoop. Okay, obviously installing it on your computer is going to be helpful, but I'm not going to mandate everyone to download and install Hadoop because it's quite big. So the Hortonworks Sandbox distribution itself is already around 20 gigabytes, which is a lot. And then, if you install the Virtualbox and then configure the Hadoop Sandbox distribution, that is going to require another, I don't know, I haven't really checked, but around 50 gigabytes in total. So that's large amount of data, and then unless you have enough hard drive space, um, things will be quite difficult. And knowing that everyone is under this remote mode, and then access to the computer labs is not easy. So I'm not going to require you to use, I'm not going to require you to install Hadoop on your computer. Instead, we'll actually learn everything through Google Colab, which doesn't require you to install anything. But I'm showing this, as an example, and in case you are curious how things work. And I'll be showing you the Hadoop configured on my local computer a couple of times throughout the semester, just to show you how things work. But again, you don't really need to, replicate that on your computer. So anyways, back to where I was. This is the thing called a Hive. Hive is a technology that is at the core of Hadoop ecosystem, and it allows you to interact with the Hadoop database as if you're using a SQL server. So again, if you don't know what SQL is, that's all right for now. I'm just showing you the capabilities of Hadoop so that you're enoughly motivated. So what I'm doing here is I just click the upload table button, and then that will lead you to this screen where I can choose a file. And then here, I've downloaded a CSV file that contains some baseball data set. So I have two CSV files, one CSV file that contains the information of all the players who ever played in MLB, in Major League Baseball. And then I have another CSV file that contains all the records of the pitchers in the history of Major League Baseball. So it's really large. Those are really large files. So let's say I click pitching.csv and then click open. And then after a while, it'll show you a preview of how the data look like. There you go. So you can see that the preview of the data set. You can see there are columns with different column headers. So there's a column for player ID, year ID, stint. I don't exactly know what that is, but team ID, lots of IDs, and number of wins and number of loses. Number of games played, a lot of baseball statistics is available here. So you can see the ERA, and, a lot of different stats. And then you can also go to this setting button, because it seems like the first row of the CSV file has been incorrectly recognized as a data. So you can click the little gear over there, and then you can check this is first row header, and then close. And now you see that the column names has been changed accordingly. You can also manually specify the data type. So year ID obviously is the integer, so I'm going to convert it to integer. In today's example, I'm going to just play with the number of wins, and the number of wins is what we care, and then we're going to convert it to integer, number of lose to integer, and that's about it. And then you can click upload table, which is going to take a while, especially if you don't have a very nice computer like myself. So because of that, I have prepared and uploaded everything before coming to the class. So I actually have everything uploaded already. Okay. So I have this table called people. I have this table called the pitching. So those are the two CSV files that I just uploaded. Okay. Now, to show you what Hive can do, well, the simplest but really quite nice feature is this graphing functionality. So here's a button called the visualization on the right-hand side of the screen. You can click this one. Sorry, I should have actually run some queries first. Well, so sorry about that. So if you click query, then there's a query editor. And then here's where you can interact with your data set with a SQL query. Again, if you know what SQL is, that's great. But even if you don't know what SQL is, don't worry, we're not going to use it. But just to show you the capability of Hadoop, I'm going to type some command. So, and to do that, I need to cheat a little bit. So first of all, I want the player ID from the pitching data set. And then I want maybe team ID and year ID, pitching dot wins, pitching dot losses. Maybe that's it. And then I also want to read the player names. So people dot, is it first name or name first? Name first. So this is the column that contains the first name of the players. And then people dot name last. Okay, and then I want to load that from pitching table, and I want to join that with people table, and the merging field, the key value is going to be player ID. So people dot player ID. And I'm only interested in, let's say, sorry, year ID is 1990s, okay? And then order by number wins in a descending order, and then limit that to 10. So again, if you don't know what SQL is, that's all right. What I'm doing here is just I'm reading player ID, team ID, year ID, number of wins, number of losses, name first, sorry, the first name and the last name. And then I'm extracting the information only after 1990s, because back in the days, you can see the pitchers who recorded like more than 60 wins a year, which is kind of crazy, but that was before, you know, this modern baseball. So I'm reading the information only the ones that are after 1990, and then I'm ordering my data by the number of wins in a descending order, and then I'm listing top 10. Okay, so I'm basically listing top 10 pitchers in terms of winning the game. Okay. By the way, can you guys guess who's going to be the number one? I will look for your answers on the chat window. Okay. So this is a SQL command. Okay, to compute that, and then I'll click execute. And by hitting execute, what happens is, you know, this Hive interface send the SQL commands to the Hadoop server. Of course, everything runs on my local machine because I'm not literally connected to an actual server, but I'm kind of emulating the situation. So as I click the execution, it will send the command to the Hadoop server, and then the Hadoop server will convert actually the SQL commands into an optimized code for Hadoop. And then after a few seconds of processing, it's going to spit out the result, and then that will send it to my interface, and drum roll, please. Okay, I'm seeing a lot of answers. Nolan Ryan, Greg Maddox, Randy Johnson, Roger Clemens. Wow, how old are you guys? Okay, yeah, those are good guesses. Let's see. There you go. So we have pictures ordered by the number of wins. I guess, yeah, I would agree. Actually, Randy Johnson. I don't know, that would be my guess, but he's only third, and I think that's because we're just annual win. So it's not the total wins throughout the career. It's annual record. So Randy Johnson has won 24 games in 2002, and that's actually on the top. They're on the tie, right? Justin Verlander, yes, he recorded 24 wins in 2011, in the season 2011. So you can see that how powerful it is. And in fact, this table that I have is actually fairly large. So here's sorry, again, very slow. So here's actually how the file looked like. The pitching.csv is 4 megabytes. So if a CSV file is a 4 megabyte, it's actually quite large. So we're emulating a situation where we analyze a big data about baseball, okay, using Hadoop and Hive. Okay, you can also do some visualization like this. So again, I click this visualization button on the right-hand side, and then soon I will see a graphical user interface where I can quickly plot some relationship between the tables that I selected. So for example, I'm curious about the relationship between the number of wins and the number of loss. And right now what we're seeing is actually only those top 10 players, but let me remove this. So I'm just printing all the players who ever played after 1990. And then maybe just for fun, I'm gonna add pitching.era. Sorry, I'm kind of a baseball geek, so I'm using baseball as an example. If you're not a baseball fan, I'm sorry about it. So I run execute, and what that's gonna do is to fetch all the player IDs, team IDs, year IDs, number of wins, number of loss, the ERA, the first name and last name, of the players who ever played after since 1990. And then it takes some time, but after a while, it will pull up the entire list of players who ever played after since 1990s. There you go, status succeeded. Now the Hadoop server has spit out the result of that search. Now what I'm going to do is to go to the visualization. Now I'm dragging the number of wins to the x-axis, and then number of loss on the y-axis. And Hive is going to create a nice plot showing the relationship between the number of loss, number of wins. And there you go. It's quite interesting. You see that? So there doesn't seem to be much of correlation between number of wins and number of loss, right? Maybe, right? But the correlation is quite weak. Obviously, if you have a larger number of wins, then that means you play more games, and the chance of losing the game is also very high. So you can see kind of a, you know, positive correlation between the two, but, you know, nothing really interesting. But one thing I found before coming to the class was that there was some correlation between the number of wins and number of, the ERA. ERA is the, simply speaking, how much points or score, an average, you're giving to the other team. So as a pitcher, that's an important metric of your performance, right? You don't want to allow the score to the other team. And as you can see, there is this kind of trend that is decreasing. Wow, the ERA of some player is over 160, which is kind of crazy. Joe Hudson. Okay. Well, anyways, you can see that the ERA is kind of, you know, going down, and then the good pitchers, right? The pitchers who recorded a lot of wins, they obviously have a very small ERA, and that's how you win the game, right? By not allowing lots of scores for the other teams. So this was kind of a brief overview of what Hadoop can do, and, you know, how to install Hadoop and things like that. So I hope that was enough motivation for you. So once you master how to use Hadoop and Apache Spark, you're going to learn, you're going to be able to handle whatever data that is given to you. It's a very, very powerful tool, powerful tool set to have in your toolbox. And from next week, we're going to talk about how actually we could utilize this. And then we'll do all this, fun analytics problems from the next week. So again, you don't have to install Hadoop on your computer, because from the next week, what we're going to learn actually is, instead of using this Hadoop Sandbox, we are going to use Google Colab. And then we're going to install Apache Spark on Google Colab, and then use that as our kind of a virtual machine. So again, this was just for a demonstration purpose. So if you're worried that you don't have enough hard drive space, or if you're worried that your computer is so slow, that's not a problem, because we're going to rely on only the Google Colab. So I hope that was helpful. And thank you for coming to the class today, and I'll see you guys on the next week.